This video is sponsored by DF Robot and PCBWay. How's it going, everyone? In the last video I covered how to get set up with the ESP32 cam for Wi-Fi security cameras using a very well developed Arduino web server code with loads of handy features. Having played around with the camera long enough, I decided to embark on the journey of making a fully equipped 3D printed solar Wi-Fi security camera, all based on an ESP32 cam. Instead of going out and just purchasing a security camera, I thought, what the heck, I'll take on the challenge of developing my own one from the ground up, utilizing the best of the camera web server's capable features. If you want to get started with the ESP32 cam, I'd highly suggest you watch my last video instructing on loading the code and how to operate it. Before we move on, could you do me a favor and please leave a thumbs up on the video in advance? I'd appreciate it. So in December of 2022, on an A4 sheet of paper, I started designing a rough sketch of what I wanted the camera to look like. I then received a sponsored package with the camera's parts I ordered from dfrobot.com. In one box I got a battery holder module, in the other a 6-volt solar panel, and a whole bunch of other parts which I unpacked, such as a large antenna, cooling fan, servo motors, different sensors, power management modules, and last but certainly not least, an ESP32 cam board. You can find purchase links to all these parts in the description. dfrobot.com is a great online electronics store for makers that offers a decent selection of high-quality parts from different sensors and modules to well-known microcontrollers and even single-board computers like the Raspberry Pi to power your DIY robotic projects. There's many options for ESP32 development boards, a wide variety of different sensors, and even a good selection of power converter boards and solar panels to run off-grid projects like a security camera as an example. Check out their website, dfrobot.com, to see what might interest you out of the many other categories of unique electronic parts that they sell. Click the link in the description below. Aside from what they sent me, additionally, I put in my own parts and materials like some wire, bolts, batteries, IR sensors, an image sensor, fancy push button, and a pack of threaded inserts, all of which cost me $60 retail from Amazon. Combined with the rest, here's all of the modules and parts that will make up the camera. So I pulled out my handy calipers and took measurements of each and every part before designing the camera parts in a CAD program. I then opened up Fusion 360 on my computer and got to work 3D designing the security camera based on my 2D sketches. The design process involved hollowing out the camera body, chamfering edges, providing accurate measurements to holes and fittings for parts to poke out through, a lot of attention on detail even internally. I also had to figure out a way for the two body shells to close together tightly. Then I focused more on surrounding parts like the camera supports and swiveling joints. The whole 3D designing process itself took up about 2 weeks of my focus. When I got the camera to look to my satisfaction, I exported the parts into an STL file for submission for PCBWay.com. I also managed to design a ball and socket joint pair to hold the camera's solar panel. I ordered both designs, got a bit too impatient, and pulled them out of the digital world, one by one, leaving me with a whole bunch of parts which I could already start working on. 3D screen printing is on a whole different level. Just look at the beautiful parts I'm now left with. Just playing with you. This project was also made possible thanks to sponsors at PCBWay. I opened up the package of 3D printed parts sent to me based on my submitted designs on their website. If you ever need anything 3D printed for your own projects, try out PCBWay.com. They also offer other services such as CNC metal machining, injection molding, PCB manufacturing, and more. Whatever project idea it is you have, PCBWay can help bring it to life. Click the link below to try out their services. Having all of the camera parts in white printed out of polycarbonate, which is known to be a good roofing material that's resistant to the sun's UV rays, will make this quite the durable camera. And I received my second submitted design, the ball joint pieces printed in nylon. As expected, I had to then do some sanding and scraping of rough edges to get the camera parts to my perfection. Keeping in mind this is my first experience with 3D printed parts, not all things were meant to turn out perfect. I had to grind out the holes a little wider to get certain parts to fit in nicely, such as the night vision sensors and the lid bolts. My idea with the double-edged sealant rim didn't make the two shells close together, so I sanded the top piece down flat, and with some silicone this would be enough to get a watertight seal. So with the surfaces on all the parts sanded smooth, I went on to mask taping away any areas I wanted to leave unpainted. I decided to paint only the camera arm, pipe mount, and wall mount pieces in black, leaving the security camera body itself in white for a black and white contrasting theme. After peeling away all the masking tape and checking to see that the parts fit together through the unpainted parts, maintaining the black look on the outside, I went on to installing the threaded inserts. I decided to use what seemed like the right size, this pack of 3M brass threaded inserts. I began by installing them into parts which needed them with a soldering iron, heating up and pushing one at a time into the plastic as it gets melted. So now I've just finished embedding all of the threaded inserts into the camera parts that needed them, including the pipe and wall mount for the camera arm piece, the top shell to the camera body, and the bottom shell of the camera body itself with 23 threaded inserts. The two pieces go together pretty nicely, especially once bolted, then there is quite a good seal, except of course I'll need to silicone the two. That'll be done once all the parts are in. Speaking of which, the next step will be making the circuit itself for the camera. For the circuit, we'll be using the parts sent to me by DFRobot. Let's do it. So I got to my desk and on a sheet of paper started designing the full circuit diagram illustrating how all the components and modules should be wired together. Next, I came up with a quick test circuit to start with so I could see that the servos and motion sensors work well with the ESP cam. Part of how I knew I could have so many modules to run as on the diagram was because I initially measured and added up the maximum current draw of each and every module to get a max instantaneous current draw of under an amp, resulting in 2 to 4 watts of power which will be pulled from the whole circuit. I made a mistake. Guys, just as I'm part way into making the project work, something just had to go wrong.
Please, no! No!
Guess what? I ended up frying the 18650 battery shield sent to me by DFRobot.
No! No!
It had a boost converter on the back. Now that's fried because I stuck the batteries in the wrong way even when it told me not to. It was a bit dark and I was in a rush at that time. Learned my lesson. I hope. But there's always a workaround. I guess I'll just have to bypass all of its fancy features and just use the battery shield as a battery holder. That's it. Let's move on with the project. This is an I2S MEMS microphone module which works with digital signals and is the only type the ESP32 cam could support. Here's a sound test. Testing, 1, 2, 3. I am doing a sound test. Sounded good enough for my security camera. If only I could get this ESP32C3 chip going as an I/O extender to run the remaining motors and sensors while having the mic hooked up to the ESP. So as of now, I got the ESP32 cam to work with all the different sensors I want it to be connected with. Though unfortunately, I'll have to kick out the microphone from this project since I couldn't get the ESP32C3 I/O extender chip going, since there's limited information about it and literally no tutorials out there on how to program it. I had to remove one sensor that took up too many pins. So this should wrap up my components and parts testing at the computer, and I should be able to make a final circuit sort of according to this diagram with a few little adjustments, as this was a rough one, and then put things into the camera shell, completing the camera. Let's do it. Because I wanted to implement this fancy push switch, it requires a specific circuit to make it latch. Yes, a latching switch circuit. Actually, the simplest one possible based on a MOSFET, some transistors, and passive components. Credits to Dave from EVblog for the diagram. So I first popped in the components on a breadboard to confirm that the circuit indeed would work. Yup, no issues here. Then I converted it to protoboard form for a more permanent integration. To tidy up connections during wiring to the ESP camera, thought I'd make this convenient ESP32 board shield that connects modules with similar connectors all to one spot and diverts power accordingly. It clips onto the back of the camera board, keeping connections much more tidy. I also made adjustments to any sensors that needed certain components extended with wires to make things adapt according to how I designed the internals of the camera shell. Same goes for this solar power management module with its connectors. Next, I moved on to prepping some power connections with more wire. In case you were wondering, this is the TS80P model soldering iron that I'm using from Miniware to make the camera's connections. You can find a purchase link to it below in the video description. A reliable iron that I can highly recommend for your workbench. Consider checking it out. With most of the modules pre-wired, I started putting together the circuit. So the next step is to get the camera's guts into the shell and wire them. After fitting in the motion sensors, I went on to inserting the pair of infrared LEDs with light sensors. Certain parts as such were well off simply being glued and sealed around the edges with hot glue or super glue. Before I got the camera module installed, I took measurements for cutting a thin sheet of clear plastic that goes in front of the lens, protecting it from dust and liquids. Then came the time to secure the ESP32 cam. I just admire how well things fit at this stage. A lot comes down to what adjustments you make in the 3D design process. With the front parts already in, I then focused on getting the rear end components into the shell, including the push button, antenna SMA connector, and the tiny 5-volt cooling fan. In the design process, I left a little square hole for servo motor and solar panel cables to fit through. For the pan and tilt motors, I chose these 5-volt 2.5 kg torque micro metal gear servos. These are more than strong enough to move this camera around. Once I got the motor in, I could fasten it with a pair of bolts thanks to the threaded inserts I added earlier. This was the tilt motor. To install the pan servo motor into the camera arm, I had to really go to town, sanding all 4 of its sides down enough so it could fit in. Using up the remaining hole space, I pulled through a couple of wires from this USB cable for the solar panel's connection, hooked up the button switch to the latching circuit, and secured it with a dabble of hot glue in the far corner. I shoved in and secured the battery holder module, making good use of the remaining space. It worked out good also for hiding any underlying wires. The solar power management module can get pretty warm, so I thought installing the included heatsink would work in well with the air-cooled space inside. With everything in the camera shell, I could then further continue wiring modules to each other. At this point, the circuit was all wired up and could finally take this pair of 2500 mAh 18650 cells which sit in parallel with each other, doubling the capacity to 5000 mAh. Pressing the button on the rear once turns on the security camera and can then be accessed via its web server online through any device. So I logged in testing the servos and the camera feed to see that things worked just fine, until I realized that the camera kept resetting after each spike in current draw from the servos. I combated this issue by soldering a 470 microfarad capacitor to the power input terminals of the ESP32 cam for stabilizing power during such spikes. Afterwards, the camera ran okay for some time while testing the servos under no load. Having more confidence with the camera's overall working status, I sealed the camera lid shut by first applying a line of adhesive silicone around the edges and then tightening the lid with 8 bolts. After wiping off excess silicone from around the camera, you can notice how well it filled different gaps and created a lasting silicone lip that will handle having the lid taken off and put back on whenever needed. I also filled some silicone into any remaining gaps. Next, I put together this pan and tilt supporting piece with the included servo horns and wheels and started attaching the camera body to the arm. I then screwed on this big antenna, which I thought would suit the camera's overall look and provide better signal. In mounting the solar panel, I chose to use the steel shaft of a longer screwdriver, which I had to smash the handle off to get to. I could now glue and shove the ball piece onto the rod, then I glued the socket mount onto the back of this 6-volt solar panel. Sticking the rod into the camera arm further back, I could clip the solar panel onto the ball, securing a good adjustable fit. To tidy up the solar power cable, I secured and wrapped it all the way up to the panel with some super glue. For the camera's pipe mount, I drilled a couple of holes in this 1-inch PVC tube and gave it a layer of matching paint. With a couple of screws installed, this made the pipe mount one solid piece. The camera with its arm could now slide on and later get secured with a screw, so it's nearly impossible to steal. So now that the camera is fully assembled and ready for installation, before we install it, I thought it'd be worth just to give it a quick test on the bench. So I'll turn it around, press on the power button back here. Just a quick press. Don't know if you hear it, but the fan is just turned on. Oh, robo camera initiated. Now just press reload on the IP address that I've typed in earlier, and it should connect to the camera web server which it's programmed with. There we go. So I should be able to press start stream and it'll start streaming what the camera is currently seeing. It's quite laggy since I'm pretty far away from my router in a different room. What we want to really test is how the servo motors move the camera around. So I'm going to go into camera control and then adjust the camera tilt slider to make the camera tilt up. Oh, now it's straight. Tilt it up a bit more. Really cool. And then down. Oh. Looks like some servo speed adjustment would need to be made there. So what I did next was partially disassemble things to weatherproof the lower servo with some hot glue. If I didn't do this, water would fill up the servo cavity. Now comes the time for installation. I whacked a decent stick into the ground firmly enough so it could support the camera, followed by the pipe and its mount. The camera with its arm could now slide on and get secured with a little screw at the top. A single press of the power button makes the camera turn on and straighten to its default position. With the sun out and the camera running, it takes up to 8 or more hours of direct sunlight to fully charge. The cooling fan at the back does its job of blowing air through the internal circuitry and out through the front air vents, cooling the camera down by about 5 to 10 degrees Celsius. So now I've got my phone out, I'm in the camera web server online, and I'm about to test out how it pans left and right after having adjusted the servo motor speed to a delay of 35 milliseconds between each degree, resulting in this kind of motion. It's a bit slower, but much smoother. Before, it was quite jerky and it would just yank its head sideways, and that actually pulled on the current so much that the ESP32 cam just shut down, restarted. In that sense, it was a pain in the butt having to reset it all the time. So this solves that dilemma. Now I'm gonna pan it all the way to the right towards me, just like that. And then all the way to the left. Right back up, and then down. So cool seeing my first ever 3D printed creation come to life. So the way this camera detects motion is no longer through the image sensor, through visual motion detection, but instead the PIR motion sensors on the cheeks of this camera. So there's one on each side with a 100-degree field of vision. You could stand behind the camera, slightly off to the side, start running or whatever, and it'll detect you. Or you could be way in front, and it'll detect you from either of the two motion sensors. The recording symbol at the top starts blinking, and this message saying "Capture started by PIR" shows up on the screen. But getting the PIR sensors working required me to place a filtering capacitor and diode at the signal pin of each one to prevent false triggering. I can now take breaks between my work and switch to the camera web server tab to monitor the camera's live feed and tilt or pan to observe further surroundings. The way I extract footage from the camera is as simple as going to the Playback and File Transfers tab, selecting and downloading the files one by one after previewing them, saving them to my device this way. I can later go to the footage folder on my PC and play back the video clips I downloaded. Unlike what I heard about only using 4GB cards, I learned that you can actually use memory cards with a larger storage, such as this 32GB microSD card, and fill them up all the way. So another adjustment I had to make to the camera was to remove the IR filter for night vision. I did this by unclipping the 5-megapixel image sensor and stripping it apart to remove the little glass filter. Believe me when I say this, it's one fiddly process that requires extreme care to prevent from damaging the image sensor chip. I'm just glad that I succeeded doing this in the first try. So I soldered and glued it back together, then clipped it back into the camera. The IR LEDs provide just enough infrared light to emit up to a distance of 4 meters, light that can only be picked up by unfiltered cameras. And yes, this does mean that during the day, the colors won't be as vibrant as they used to, such as any greenery, but I don't have an issue with this. In the rain, the camera handles being wet, deflecting water from dripping into the camera's air vents, all by my design. I also had this wall mount 3D printed in case I wanted to mount the camera on the eave of a roof like up here. If this camera runs in areas that lack sunlight, USB power through a phone charger can keep it powered instead. Here's my first ESP32 cam security camera and my new version side by side. Even though the ESP32 security camera may not yet be set up for FTP file transfer, nor is it cloud hosted to be accessed when I'm away from home, it still has come a long way from being a plain idea to being 2D sketched, 3D designed, printed, then assembled into a functional handmade robotic camera that runs off the sun's energy. Despite facing a handful of setbacks and mistakes along the way, it has overall been a very rewarding journey and learning curve, having my first ever 3D design actually come to life. Right over there. Once again, I thank my sponsors at DF Robot and PCBWay for making this project possible. To try out their products and services for your own projects, click the links below and see what they have to offer. If you're planning to make a similar camera of your own, just so you know, I'm selling the 3D designs of this very same security camera. You can contact me through email or in the DMs of my Instagram page on how to go about purchasing your own copy of the 3D designs. Circuit diagrams and code can be found linked in the description below for free. If you appreciate what I do here on the channel and would like to show some support, then feel free to buy me a coffee through the link in the description below the video. As per usual, consider leaving a like, subscribing, and sharing this video. See you with another one. Peace.